Okay, multiplication rules for probability. The key to this one is the word and. Let me write that up there. If you see or with probability, that generally means addition, and the word and means multiplication. So we've got two events occurring, and independent events is kind of the easiest one. That's when the two events do not affect each other. It won't affect each other's probability. So in this case here, I've got a coin and a dice. And so you can, oops, let me put the marker down so that there we go. We can roll the coin, stop it, and we can roll the dice independently, and their probabilities have nothing to do with each other. So let's just look at this one. What is the probability of rolling a head or flipping a head and rolling a 5? So the probability of an H and a 5, and the probability of flipping a coin to get a head is a half, and the probability of flipping or rolling a dice is there's 1/5 out of 6 total. So your probability of both is occurring at the same time when you do them both is 1/12. So it's just multiplication. And so I guess if you were going to do this nicely, you would say, and I kind of was naughty there and was getting lazy, but you'd probably define your events. So A would be um, uh, flipping a head or getting a head, or maybe just that's just what we'll call it. A is head, and B is rolling a 5 on a dice. And so that's 1/12. And so those are independent events. We'll talk about dependent a little later. We'll just stick with independent for this video because dependent's a little more complicated and takes some more time. So let's head back to the deck of cards now. So with independent events in cards, what's going to happen is you're going to draw a card, then put the card back in the deck, shuffle them up, and draw another card. And so let's let event A be um, drawing a diamond, since I'm staring at them. And event B, and we'll be very specific, drawing a diamond on the first card, on the first draw. And event B, drawing a king on the second draw. Okay, so I'm going to draw two different times. Wow, sorry, that's so sloppy. And so the probability of A of drawing a diamond the first time, well, there's 13 diamonds out of 52 cards, and you could use the simplified version of that, 1/4. And the probability of B drawing a king on the second draw, and remember, each time we're replacing the card. And so we're going to look at this situation again with dependent events where we don't replace the card. But if you replace the card, shuffle it up, make sure it's fair again. And there are 4 kings out of 52 cards, which would be 1 out of 13. So the probability of drawing a diamond on the first draw and a king on the second draw would be 1/4 times 1/13, or 1 out of 52. So there's that. Let me set up the next situation where these can get kind of complicated. Okay, so here's another situation. Let's get away from cards because that can get pretty messy, and if you're not familiar with it, it's not a good thing. So let's say we had 3 red marbles. I've got them roughly drawn here. 3 red marbles and 2 black marbles in a bag. And we're going to draw 2 marbles out of that at random with replacement. Excuse me, with replacement. That's key here. So I'm going to take a marble out, put it back in, shake the bag up, take another marble out. What is the probability of drawing 2 red marbles? So the probability of drawing a red marble the first time is 3 out of 5. The probability of drawing a red marble the second time would be, again, 3 out of 5. So the probability of drawing 2 red marbles while we replace the first one is 9 out of 25. Now, the reason I chose this is you could come up with, we need to have all events listed. You don't need to do this in your problem, but it's good to check because these problems get really complicated. I'm giving you some simple ones. 9 out of 25. So where are that means there's 25 possibilities here. Where are the rest of them? Well, you could have all of them would be, let's say, the probability of 2 black marbles. Again, we're replacing each time, and so 2 blacks, that would be 2 out of 5, and then you put it back in the bag, and then that means you got 2 out of 5 again, or 4 out of 25. So we're getting closer. We've got 13 of them, so we're still missing 12. Well, you could have the probability of a red and black in that order, or the probability of a black and red in that order. And so the probability of a red and black, so a probability of the red, you get a red the first time, is 3 out of 5, and the probability you get a black on the first time is 2 out of 5, which would be 6 out of 25. The probability that you get a black the first time is 2 out of 5, and the probability that you get a red the second time is 3 out of 5. And so that would be 6 out of 25. And if you add that up, we found all 100%, all 25 of them. So we have every possible situation in this where we draw 2 marbles. Because 9, 4, 6, and 6 gives you 25 out of 25 total. I know that's beyond what we needed to do there, but that kind of gives you a way of checking your work and to see, you need to know where all the situations are, because what if I had asked you what's the probability of getting a red and a black marble? Well, if order doesn't matter, it's 12 out of 25. But if I want the red specifically first and the black specifically second, it's only 6 out of 25. And so you want to be real careful with that kind of stuff. And that's what makes this so fun to me, because it's so challenging. Granted, I'm giving you somewhat easy examples, but they can get really ugly in a real hurry. So thanks a lot. Best of luck on these, and see you next time.